In this video, we introduce Prim's algorithm and see an example of how it can be applied. Prim's algorithm is a method for growing a minimum spanning tree for a weighted connected graph. The method proceeds by applying these three steps. First, we pick any vertex as the root of our minimum spanning tree. We then find the minimally weighted edge that leaves that root and add it to the tree. We repeat this step, in other words, finding the minimally weighted edges leaving the tree and add those to the tree until all vertices are included. Once we've reached this stage, we have the minimum spanning tree. Let's take a look at this example. Shown in green is a connected graph, and we're going to find the minimal spanning tree for this graph. Now remember, the first thing we need to do is just choose any node that we like. Now without any other reason than simply alphabetical order, I'm going to start with node A. Having chosen node A, I now look at the edges that leave A. We have an edge that goes from A to B with a weighting of 5 and an edge from A to C with a weighting of 9. Now the smallest of these is of course from A to B with a weighting of 5, so let's take that one and add B to our minimal spanning tree. Now we look at the minimal spanning tree as a whole and look at the edges that leave it. Leaving our tree we have B to E weighted 11, B to D weighted 9, B to C weighted 10, and also A to C weighted 9. The smallest of these is either A to C or B to D, both weighted 9. So we can really take our pick here. I'm going to pick from B to D and add that to my minimal spanning tree. Now we repeat the steps again. Look at the edges leaving the tree and try to choose the one that's the smallest weight. Maybe pause the video and have a go at this one yourself before I continue. So I can see that we have an edge from B to E weighted 11, from D to E weighted 8, from D to F weighted 10, D to C weighted 3, B to C weighted 10, and A to C weighted 9. The smallest of these, of course, is the weighting of 3, linking D to C. So we add C to our minimal spanning tree along the edge from D to C. Now we repeat once more. Looking for the smallest edge leaving our tree, we can see that C to F is the smallest with a weighting of 2. Try pausing the video now and try to finish off the minimal spanning tree. Come back in a couple of seconds and see if you get what I get. Okay, so while you were gone, I worked on the F to G link with a weighting of 3, that was the smallest one that came next, and then from F up to E with a weighting of 6. So you can see now that we have our minimal spanning tree for the weighted connected graph in our picture. We've got A to B, B to D, D to C, C to F, F to G and F to E. We've got all of our vertices included and we can see that there's no circuits, so we can consider our minimal spanning tree to be completed. So there we have an example of Prim's algorithm for finding a minimally spanning tree for a connected weighted graph. Just to recap, we pick any vertex as the root and then find the minimally weighted edge that leaves that root. And then we repeat that until we've included all vertices in our tree. So in other words, finding the minimally weighted edges, leaving the tree as it exists, and continuing until all vertices are included in our tree.